this module, we will just take a very quick look at some of the basic commands that we do make use of for administering a local Linux system. So, the first command that we will typically require after we have actually partitioned a disk or we have received a partitioned disk is for us to make use of a command called mkfs. Now, what exactly this mkfs command does is that mkfs basically creates the file system. So, in our initial set of modules, we had a very brief look at what a file system is all about. Typically, without creating the file system, we would not be able to store files in the disk partition that we have unless and until we want to access it as a raw partition, like just like typically how databases make use of. But other than the databases part of it, if you want to really store data in it in terms of logical files, one of the first requirements for us to have this kind of utility is that we need to first create a file system on the disk partition. So, the mkfs command is the way by which we will be able to create a file system, so that the disk partition is having a very clear metadata information stored inside that exactly tells where the different data blocks are available and where for a particular file the corresponding data is actually stored, right. So, we had discussed about the inodes and the data blocks inside the inodes in our previous module, and on a typical system, if you take any kind of a Unix flavor, you have different types of file systems that is actually supported. So, you have something like an ext2, you have a ext3, ext4, riserfs, xfs, so many different file systems that are possible, and most of the times we try to differentiate the file system decision by trying to understand what kind of data we are actually trying to store on that. So, there are different kind of functionalities that are provided by different file systems. So, depending on our specific requirement of what type of data we intend to store on the file system, we basically decide what is the type of file system that we want to create on that particular partition. So, one way which we will take a look at is I want to create, for example, a file system called as a ext2 file system. So, mkfs .ext2 is the name of the command that I will make use of, and then I specify /dev/sda1. So, dev sda1 is basically the first raw partition of my first disk, right, and I am basically saying that I want to create a ext2 type of a file system on this particular first partition in my first hard disk that has been detected by my OS, right. Now, other way by which I could actually create a file system is if I want to basically create a disk image file. So, I am sort of mimicking a file system on a local disk that file that I have. I can also use -f option for doing that, wherein I can run the mkfs.ext2 command and use -f and then say disk.img, right. So, the -f option basically will go ahead and create the file system even when the file that has been given is not a real physical device, but a sort of a soft file that is actually available on an existing file system itself. So, that is why I was just mentioning it as a file that will sort of mimic a file system or a disk partition at the lower level. Suppose if I want to basically have a different type of file system created, so I could say mkfs.vfat. So, vfat is originally from the Windows world. It is a type of a file system that was actually available in the Windows, and those file systems that are supported only on Windows is also you have the support of those file systems in our Linux distributions, right. So, I could say mkfs.vfat and then do appropriately create a vfat fs on whatever disk partition that I have been that has been mentioned, right. So, likewise if I want to for example create an XFS file system. So, XFS is another type of a file system. I would similarly run a command called mkfs.xfs, right. Pretty much the arguments will continue to be turning out to be the same, but you can have more details of it if you run the man command and give mkfs as an argument to the man command, where it will display you the complete details of how this particular mkfs command has actually got to be made use of, right. So, for example if I want to create a blank file which I want to use in my mkfs creation, like how we have used here with the -f option called disk.img, there is a command called dd. So, dd basically stands for disk device or device dump, where I specify if is basically the input file, what is the input file that I should use for creating the file, and then OF is basically the output file. So, if I say /dev/0 as my input file, /dev/0 is basically a very special file, one of the special files which Linux exposes, which will basically give a stream of zeros as the bytes whenever that file is read. So, whenever I open this file dev0, which is basically what the if option to dd command is going to do, it will continuously, the driver will basically give it a stream of 0 bytes, and that stream of 0 bytes will be dumped onto this OF, that is the output file here, right. So, disk.img will basically be getting created with all the every bytes initialized as a 0 byte with a block size of 1 MB. So, every input and output on this particular file will be done in the block size of 1 MB, and this will be done 64 times. So, the file size will be 64 into 1 MB, right. So, how many times it will be done into what is the size every time I do it. So, that basically becomes 64 into 1 MB, which is basically what is a 64 MB file that will be created by running the dd command in this form. So, dd command is actually is typically used to create a disk file of a very large size, and you could actually have all bytes in that file that you have created to be also initialized with zeros rather than having some junk characters by trying to have the if argument as /dev/0. Once I create a file system, how do I actually mount it? Because unless and until we mount that file system, we will not be able to access the data that is there inside the file system, and neither create new data inside the file system, right. So, for that we typically use the mount command. Whenever we use the mount command, one of the first requirements is that we should have a mount point on the system, right. So, the mount point is basically the point in my entire file system hierarchy where this particular raw partition or my removable media is going to get mounted on, right. So, first I use the mkdir command and create the mount point if for example that mount point is not already available, right. So, once I have created that mount point whenever it is required. So, this is basically a one time activity that we will do till such time that I do not have the mount point. So, once I do that creation with this mkdir, so creation of the mount point with this mkdir, subsequently every time for me to when I mount it, I do not need to keep creating it again and again, right. As long as I create it on the disk and not let us say something under my /tmp directory, because anything that is created under /tmp directory will not be available to you across the reboots. So, as long as I do not create my mount point under /tmp for a particular system, the mount point creation with the mkdir command is typically an activity that will be done only once, right. So, once I run the mkdir command once on my system and create this mount point, I will basically go ahead and try to mount with the mount command. So, the mount I specify the -t option. So, the -t is basically the option to specify what is the file system format that is actually available on that particular disk partition that is getting mounted. So, if for example it is a vfat file system, I say mount -t vfat followed by /dev/sda1. So, that is basically the disk partition that is mentioned that is right now required to be mounted, and I also specify what is the mount point on which it has to be mounted, right. So, this raw partition /dev/sda1 which is containing a vfat file system which I have created before with the mkfs command that we saw in the last slide. Now, I am telling with the mount command this particular file system that is available on dev sda1 should be mounted on to this mount point, right. So, if I had for example created let us say an ext3 file system or ext4 file system on this mount point, I would have appropriately mentioned that particular file system type as an argument to -t here, right. And if that was really the file system that had been created on the partition, then the mount command will be successful and I will be able to mount it. So, once I mount it, I will now typically do a change directory into this particular mount point, right. So, I will say cd /mnt/usb disk and whatever data was actually available in this particular raw disk partition will now be available for me to access under this particular directory, right. So, that is basically why we call this argument as the mount point. So, what is the mount point in my entire file system hierarchy in which the data that I have created originally here on this raw partition is going to be available to me right now. So, that is basically what the mount command is actually helping us with, because without the mount command of that particular disk partition it is not possible for us to access the data inside that partition. So, I could also make use of what is called as a loop type of device for mounting, especially if I have a CD-ROM image, right. So, we call it as an ISO file system. So, any kind of a CD-ROM image that I want to mount it locally as like a normal file system, I use the -o option, right. -o to the mount command is basically stands for option. So, the -o and then I say loop. So, I am basically telling that this is a kind of a loop device that is internally containing the entire file system image, right. And this file system image I am now telling is basically a vfat file system type, and this is the file system image file that is available, and I want this file system image file to be mounted as this particular on this particular mount point, right. So, whenever I have a CD image, we basically try to use this kind of mount option to have the contents of the file system on the CD mounted as if it is like a file system available on my local hard disk, right. So, Linux allows me to actually mount them as a special device called as a loop device using this small customization or a small additional option specified with my existing mount command. So, if I basically want to find out what kind of file systems are available or mounted on my system currently, I just run the mount command and then it displays me all the mounted file systems, right. So, for example, it says /dev/sda6 is mounted on /. So, that means / that is the root is the mount point for this partition, and it is of the type of ext3, and what kind of options have been used, it is specifying RW and no access time. So, these are like different options that are possible to be specified whenever we run the mount command. So, very similar to the -o that we specify here. So, I could for example say -o RW, and then it will mean that this particular file system has to be mounted as read write as well and not just as read only. So, if I wanted to be mounting as read only, any kind of modification that I try to do on the file system. So, whether I am trying to create a new file, whether I am trying to modify an existing file, all these kind of operations will be not allowed at that particular point in time when the file system has been mounted as read only. So, it has to be mounted as read write, only then any kind of modification operations on the file system, either creating a file, modify an existing file, all those things will be allowed. So, if I want to basically unmount file system, I could either specify the file system mount point, or I could specify the corresponding partition and then run the command called unmount. So, that is basically like umount. So, umount stands for unmount. So, umount I can specify the corresponding partition which has been mounted, or I could also specify the mount point. Both are accepted as arguments by umount. So, unless and until all processes that are using this particular file system has stopped using it. So, suppose if I have a shell process in which I have gone inside a directory which is available in that particular file system, right. If I have done a cd into a directory inside that file system, and I on another shell prompt try to unmount it, that I basically try to umount it, Unix system will not allow me to do that, because my shell process is marked this particular file system as busy, right, because one shell process is right now the current directory is inside this particular file system. So, to be able to unmount the device, I have to basically have all the open files within the file system to be closed. So, how can I do it? So, I will have to basically close all the applications that have data opened in this particular mounted file system, and then as I was telling, I should not have any of my shells have the working directory in this mount point. And if I want to basically find out which is actually using any kind of data inside this file system, I have a command called lsof. So, lsof basically stands for list open files, right. So, it basically will tell which processor still has open files in that particular mounted partition, right. So, on some distributions this might not be available by default, but it is definitely downloadable and then installed, which could come in handy for the system administrator whenever he has to basically sort of dynamically mount and unmount file systems, especially when lot of removable media is used, like USB pen drives and those kind of media stuffs. So, any kind of software is installed with a command called as an aptget. So, these are what is called as packages. So, any kind of an application from the Linux point of view is referred to as a package, which is typically stored in Linux distribution repositories. So, there will be different repositories which are accessible either over HTTP or over FTP, depending on what is the command line tool that we are using to download a package and then install it on our local system, right. So, by default whenever we try to install a Linux distribution, there will be a basic set of packages that comes in with the default installation, but over and above that there are thousands of packages that are available. So, the thousands of different applications and tools that are available, which we could optionally download and install. And on a distribution like a Debian or Ubuntu distribution, you can actually run the command called sudo aptget update to update my list of repositories on my local system, which is what will be referred whenever I try to do a installation of a new package, right. So, once I do the repository update, so it will go ahead and update the entire set of repository list that is available for this particular distribution version, after which I could actually go ahead and do a aptget install of whatever package I want to download and install on my local system, right. So, this command will now download the package, check for the dependencies to be available on the local system. If there are any dependencies, it will query you whether you want to install those dependencies also. If you give a concurrence for that, it will first go ahead and install the dependencies and then go ahead and install this particular package, right. Now, another most commonly used command is once we are done using the package, for any reason we want to remove the package, we also say sudo aptget remove package. So, sudo is basically the command that was discussed in one of the previous modules, which could be made use of to temporarily run a command as a super user, right. So, aptget is a command that will work only as a super user. So, even when I have logged in as a normal user, if I want to run the aptget command, I will have to run with sudo and then I will be queried for my super user password, that is the root password on my local system. Once I type in the password correctly and the system has authenticated me as the correct root user, it will go ahead and execute the aptget command, which is basically going to either download the package from the network and then do the complete installation process, because installation process requires super user privileges for it to be successful. That is basically the reason why we do all the aptget commands under the sudo as an argument, right. So, sudo will be able will help the argument when whatever command has been given as an argument to be run as a super user and not as a normal user. If you try to run the aptget command as a normal user, it will tell an error message back saying that you do not have enough permission, or a permission denied message will come back on your terminal window. So, some of the other system administration commands that you would possibly need to use very frequently is halt or reboot. So, halt will basically halt the system, reboot will basically halt the system, but also bring up the system after the halt. So, if you want to basically shut down and then restart the system, you could run the reboot command, or alternatively in a GNU Linux based system you could also press Ctrl or delete if this key is actually mapped to the reboot command. So, that is again another way by which you could actually do. So, this basically brings us to the end of this module. Thank you.